Hello, my name is Pascal Oferov. This is Zero2Hero Action Based Extensibility in VMware Cloud Assembly, Part 2. Today we are going to talk about using extensibility tags with ABX actions, working with action functions, using REST within ABX actions, calling ABX actions via REST, and pulling action runs, calling ABX actions from VMware CodeStream, and integrating with Microsoft Azure, Microsoft Active Directory, and Amazon Web Services. I hope you enjoyed. Let's start. In part 1, we covered the building blocks of ABX actions and the building blocks of functions within those actions. If you missed that, make sure to check out the YouTube video part 1. Now let's dig a little bit deeper into ABX actions. I'm gonna open a very simple example with which we started last time as well. Let's talk first about how we can control where our ABX actions can run. First of all, we can do this via the Function as a Service Provider dropdown. As we said last time, we can either select a particular Function as a Service provider like Amazon Web Services or Microsoft Azure or on-prem, or we can leave this to auto select. We can also affect where ABX actions will run via extensibility constraints. Let me give you a quick example. Let's say we have an extensibility VA that we use for on-prem ABX actions, and we can put a constraint or capability tag on that extensibility VA. Let's take this one as an example. I'm gonna copy this tag. I'm gonna navigate back to my project where I want to set this extensibility constraint. As you can see, I already have placed that same constraint tag under extensibility constraints, and I have identified this as a soft tag. What does this mean? It means that Cloud Assembly will try to deploy my ABX action on that integration, matching that extensibility constraint, but because this is set as a soft, if it cannot, it will deploy on any available integrations. Extensibility constraints override any configured function as a service provider within our ABX actions. So even though I have selected Amazon Web Services, this action will deploy on an extensibility VA, which is an on-prem function as a service provider, because I'm overwriting this for this particular project within the project settings. This is it. Controlling where ABX actions run is very simple and straightforward. Let's talk more about the functions within our ABX actions. Let's start with the context parameter, which we discussed last time as well. And as we said, this handles authentication for us so that ABX actions can authenticate in the corresponding public cloud or on-prem extensibility VA and run successfully. Context can give us also access to some additional properties that we find useful in different use cases. So I'm going to copy an example to illustrate this. In this example, we have a context.request property or method which we can utilize. This is, think of this as your regular REST request method, but in this case, we don't have to specify or supply credentials to that request. The context of the user who starts the action will be used to execute that REST request. In this case, we can see that I have an API which is the Blueprint API from VMware Cloud Services, and I'm pointing to a particular blueprint with a particular ID that I want to query or that I want to get via REST request. Let's see what happens when I execute this. The user with which I'm running this action is a Cloud Assembly administrator. And as we can see, this action executed successfully and this action returned the contents of a blueprint that resides within Cloud Assembly. In this case, the action used my credentials to execute this particular API call. This particular method can be used only within a subset of Cloud Automation Services APIs, provisioning, the project service API, the blueprint API, the deployment API, the code stream API, and the IaaS API. This is useful to build actions that will be run by Cloud Assembly administrators or actions that will be subscribed to event topics which are going to be triggered by Cloud Assembly administrator via the deployment of different blueprints. As we said, this will take the context or the authentication of the user who triggered the action, and it's going to use that to execute the API call. Now, although this may be suitable for admins that execute actions, that may not be that suitable for actions that will be executed by end service broker users who are not necessary cloud services administrators. And to illustrate this, in a separate tab, I'm logged in to VMware Cloud Services as an end user that has VMware Service Broker user role, and I'm going to try to execute this action from the catalog. I'm going to request the action and I'm going to submit the request. I'm going to go back and check the actions, after a few seconds, I would see an action run for that particular request. That action run will fail because the user or the service broker end user doesn't have permissions to execute API calls against the cloud services APIs. We can see that the action run completed unsuccessfully because the user didn't have permissions to execute that particular API call. Let's go back to our action and check some more useful context commands. Let's trigger this again. The next command I'm gonna show is context action trigger. This is going to output from where was this action triggered. In this case, it is saying that this was triggered via the test button. If this was triggered via service broker, it would say that it was started via API, and if this was started via subscription, it's going to say that this started by an event. Where can we use this property? Let's say I have an ABX action that takes few inputs from the payload, for example, from the custom properties of machine resources. Let's say I want in my action to read the resource names from the payload. I'm going to create a variable and assign the resource names coming from the custom properties which are being taken from the inputs payload. Now, if I execute this action here from the Extensibility tab via the test button, this will fail because the payload does not exist. The payload will be generated and passed to this ABX action once an actual deployment takes place. But what if I want to supply some dummy values to that action as part of my testing here and now, so that I don't have to run multiple deployments that may take long time to complete or trigger this particular ABX action, just so that I can see if a small change in my code was successful. I'm going to create an ABX action input. I'm going to use the same name, resource names, and I'm going to say this is an example value name or a dummy name for my machine resource I want to use when I test my action from here. Now, at the beginning of my main function, I can build a very simple loop to determine from where this action was started, and depending on that, I would either take all my variables from the payload inputs, or I'm gonna take this from the action inputs. Let's build a quick if loop to showcase this. I'm gonna say if the action trigger is different than test, which we saw is the value returned if I trigger the action from here, then This means I'm triggering this via subscription or an API, so I want to read the resource names from custom properties from the payload. Else, if this is not the case, else if I'm triggering this via the test button, then take this from the action inputs. And if I have more variables which I'm reading from the payload, I will just add them in that loop. By doing this, I can test this action with dummy values from within the ABX extensibility tab itself while I'm developing the action, and without any change, the same action will run successfully and get those values from the payload once this has been triggered from a different action trigger, which can be a subscription as we said, or an API call. I would leave it up to you to decide what other usages can be found for context action trigger. Now, let's talk about functions. In this example, I have copied and created an additional function within my ABX action called my function. When this action executes, the entry function or the main function that is going to be executed is the one which I have specified here on the right, and this is handler. I can create though as many other functions as I wish. Still, handler is the only function which will return something, which may return something that will be outputted from the action itself. Any response returned from other functions will not be outputted as a response of the action unless I specify this in my handler function, as I'm gonna show in a bit. For now, let's start by creating a value, assigning creating a variable, assigning a value, and then outputting this value in our main handler function. We are also supplying this value to our second function when we call that function. And we also have specified the parameter here in the definition of the function. And within the second function, again, we are only taking that input parameter and returning this as a response of the second function. Let's start this and see what the result would be. As we can see, my main function returned my variable, which was specified here under handler response, and we can see that my second function returned the same variable which was defined here in the return response. We can see though that although these were outputted both in the console window, only the first response from my handler function was returned for the entire action. Now, what if we want to get the return from our second action and output this again and add it to the output of the entire ABX action? Let's change the variable once it is read by our second function. I'm just gonna change the value of my variable, and then I'm going to add the response of that function to the outputs of my main function. Let's see how the result looks like now. We can see now that my second function, returned a different value for that variable, which is expected, but we also can see that my main function now returns the values returned by my second function as well, together with the values returned by the main function itself. Now let's talk a bit about doing REST calls from within our actions. Doing REST calls from within our actions doesn't require anything you may not be familiar with. We can utilize the requests Python library in this case to do standard REST calls. The only thing that we will note here is that we need to specify authentication token for the API against which we are authenticating. Unfortunately, ABX actions are missing at this point way to securely store those tokens within the extensibility functionality. So if I want to specify that particular token, I will have to hard code it within my script or provide it as an input to that action. The rest of it is a standard REST call with request headers and some body which the API call understands and requires. We mentioned that there is no good way to store credentials within ABX actions in a secure manner if we are building a function as a server agnostic actions. If we are integrating though with a particular function as a service provider, let's say we are building actions that will run always on Amazon Web Services, we can utilize, for example, the AWS Secrets Manager to pull secrets which contain our securely stored credentials, passwords, tokens, IP addresses, or any other information that you want to store securely. This requires very little coding, and it only requires you to know the secret ID of the information which you want to pull from AWS Secrets Manager. This example can be found in my Git repo, which I'm going to show at the end of this presentation. Similarly, if your function as a service provider you have chosen is Microsoft Azure, the same functionality exists there as well, which you can utilize to get access to a securely stored secrets within the Secrets Manager. Now let's see how we can execute ABX actions via REST calls from other systems and pull the action runs to see if these completed successfully. Before we move to Postman that we're gonna use for this example, we're gonna need the ID of the actions, which can be found by enabling the ID column within the Actions tab. We're now gonna go in Postman, where I have prepared two actions, two API calls, which I have put from the ABX Services API library. The first one will trigger an action run, and this requires only the ID which I have just shown you. Let's trigger a new run of our action. Let's check if this action run executed, and we can see it is running. In order to pull this action run for information, we're gonna need the action run ID, which again can be pulled by enabling or showing the run ID column. I'm gonna copy this from here, and I'm gonna go back to Postman. I'm gonna paste this in my second API example, which is fetch action runs by ID. I'm gonna say send, and this gets me the current action ID run, where I can see among all the other things like inputs and outputs, I can see the run state of that particular action, which in this case is failed. We're gonna use the run state property again in a few minutes when we do similar operation from VMware CodeStream. I've went and I've copied the initial example we've used today so that the action completes successfully next time I run it. Now let's go to CodeStream. We are going to perform the same operation from within a pipeline. We're gonna need 3 tasks to accomplish this. We have a REST task that will get us a token with which we can authenticate against VMware Cloud Services, and we can get this token from the IaaS API. Next, we're gonna use a REST task within our pipeline, and we have pasted exactly the same URL which we used in Postman to trigger the action in Cloud Assembly. I've also provided some payload to that request, which just specifies again which action needs to be run, what's the name of that action, what project it belongs to, and so on. At the end, we can see under headers that I have added also authorization header, and I'm reading the bearer token which I get from my first task. This is the same request header information which you provide in a typical Python REST request that we saw earlier in our action. And in our last task, we are using a pull task, and we are supplying the second API call that we saw from the previous example, which pulls the action run every 60 seconds. And it does this 5 times to see if the action run returns a successful condition criteria or a failure condition criteria. And as you can see here, here is where we use the run state property that we saw earlier that gets returned when we pull an action run. And we have set a successful condition for us means that the run state equals completed and failure conditions will mean if the run state equals failed, deployment failed, handling error, or cancelled. Let's run this and see what happens. I already have an action run or pipeline run which I executed before, and I'm just gonna open and show that to you. In the first task, I've successfully generated a token which I'm then using, and I can see I'm getting the same response that I was getting before when running this particular call from Postman. And if I check the JSON output, again I can see the same properties that I was seeing in Postman. For example, I can again see the run state, which in this case is created because the action was just started. In the next task, I'm pulling that action to see if the run state completed or the action run completed successfully, and in this case it did, and in this case somewhere here I would see the run state which will equal successful. This was it. Running actions from CodeStream is very easy thing to do, and pulling the action runs for completions so that we can decide if we want our pipeline to continue or not, as we saw was again very easy to accomplish. Let's talk about different integrations with different systems or cloud providers. For example, let's take our previous integration, which we saw that was integrating ABX with AWS Secrets Manager to pull secrets. I'm gonna paste this again just so that you have this as a visual. You can see that in order to integrate with Amazon Web Services, I'm using and I'm importing a library called Boto3, which is a low-level library, a low-level Amazon Web Services SDK for Python. And this SDK is very extensive, and it can let you and it will allow you to administer many of the Amazon Web Services available today. You can configure DynamoDB, EC2 instances. You can configure EKS clusters or EKS services, and Elastic Load Balancers, and pretty much anything you may think of. This is my preferred way to integrate with Amazon Web Services, as the library itself is very extensive and I rarely need to search for other ways how I can accomplish something in AWS. If I'm integrating with Microsoft Azure, I can utilize PowerShell ABX actions, and I can utilize the AZ models for PowerShell. This is an example of a simple PowerShell action that connects to Azure. As we can see, we need to import a dependency. We need to import the AZ models as a dependency, and this is the newest version which is currently supported from ABX, or for the entire AZ model it should be smaller or equal to version 370. The AZ library of modules is again very extensive and offers a great way to integrate with Microsoft Azure and do different operations within that cloud. If we want to authenticate to on-prem Microsoft Active Directory, we can go in a couple of ways. We can integrate with a PowerShell ABX action, and that comes pretty straightforward. Or we can use the Python WinRM library that utilizes the Windows Remote Management Protocol to trigger commands on a Windows machine. And this example that you see here has been supplied by my colleague Ryan and is available in GitHub. I meant to say Robert Jensen, of course, not Brian. And this can be found in RH Jensen 79 VRA Extensibility. Regardless if you use PowerShell ABX or Python and WinRM libraries, the limitation from both of these methods is that only basic authentication is supported at this time. And this is a limitation coming from the Microsoft implementation of PowerShell for Linux, and the second one is a pure limitation coming from the function as a service functionality, and you would see this even if you try to run this action with Kerberos authentication in AWS Lambda or Microsoft Azure App Function. Still, if basic authentication fits your needs, examples like this can easily enable you to, for example, add DNS records using the DNS CMD on a Windows box or run any other CMD or PowerShell command on that box. And again, kudos to Robert Jensen for providing this example for using ABX with WinRM. Thank you for watching